This video here is a bit of a risk for me. I'm sort of titling it, The Celestial Sphere, Let's Do It. Now what could I possibly mean by that? Well, gosh, if we looked at a lot with the celestial sphere. We looked at drawings, graphics, animations. We looked at rising and setting of stars, circumpolar, just about everything. And so in the very last sort of let's do it here, I wanted to see if it might be possible, just from everything we've learned here, can we draw our own celestial sphere and actually capture some of the wonderful star dynamics on it? It's quite a challenge. The way I'm going to start is with the graphic I showed you in a couple of videos ago, which shows you the declination. Remember this word, declination means sort of latitude of a star, indicating its north-south position. And we looked at a few. I think we showed, here's Doobie, one of the here's Doobie here, one of the pointer stars of the Big Dipper right here. There's Arcturus that we like to arc to. We spike to Spica. Vega is another prominent star in the sky. And that's the extent of it there. So just some star references for me. And the other one that I'll add on here that isn't on this graphic here, of course, that we just learned about is Mintaka, which has a declination of 0 degrees. It's right on the equator, right? That one of the stars of the belt of the Orion. So could I take some of this information here and draw my own celestial sphere to capture some of the wonderful lessons that it tells us about our night sky? Let's just go for it. So this is the celestial sphere. Let's do it. The first thing I'll do is I'll go ahead and draw my horizon in there. And I'll put a little person in there like that. And I'm going to say that the person here is just sort of sitting sort of like maybe in his or her backyard. And I can also draw my cardinal coordinates on here. Like I know, for instance, even in my backyard, I'll have a north-south, and maybe over here I'll have an east, and over here I'll have a west, something like that, yeah? The next thing I'll do is that's sort of the horizon. So you could think of this as being all green or something like that if you would. We could color it in all green, indicating the grass in my backyard. That would be fine. I'm just out standing on a field, and again, the white line represents my horizon. I can't see over the horizon. What I do know is if I look up at the sky, I'll sort of see this wonderful dome in front of me, and that's not what I want to use to draw the dome. The dome will sort of come up like this and go down. That's the sky that I see, and we had a name for this. It was called the meridian, and remember, meridian sort of means middle. It's that line that sort of cuts my sky in half. So over in this region right here, this will be the western part of the sky. Over on the other side of this, that'll be the eastern part of the sky. And of course, directly above my head is always my zenith, and I won't draw that on here because it starts to get a little busy. Okay, so I want to start capturing some of the things that the celestial sphere model tells us about where my stars are. So I guess the first thing I'll do is, why don't we put Mintaka on here? Because Mintaka is that wonderful star that's on the celestial equator. So what we know about Mintaka, and this is where I believe the good brain work starts with the celestial sphere, is Mintaka rises in the east. So there's the east right there. And so what I'm expected to do is just sort of go up, 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 up. It's going to reach its highest point in the sky on the meridian there. Then it's going to come all the way back down again till it sets due west. And I would label this 0 degrees and label that star Mintaka. Like if I wanted to put a little white dot on there, that white dot would be exactly what Mintaka does. So all the graphics and discussion aside, I feel like I'm really using my gray matter at the moment here because I've captured the dynamics of a star the way I would see it in the sky. I know some things about Mintaka. It rises in the east, reaches some maximum point, then sets in the west. And it just does that over and over and over again. Furthermore, I didn't draw Mintaka as apexing above my head directly because I don't expect that I'm on the equator. I'm sort of in the northern hemisphere, which is where most of us are based here. And so Mintaka is going to somehow apex over the equator. So the tropics would be down here somewhere, not over my head, something like that. Okay, so there's Mintaka in there. Let's pull Arcturus out, like from the image I showed you above here. Where's Arcturus? It's right here. Here's Arcturus right here. Looks like it has a declination of 19 degrees north. And so what I'll do in here, let's see if I can capture Arcturus in here. And what I know then, maybe I'll do that in, let me pick a different color, maybe like the light green here, is I better go north because that's where Arcturus is, and it's 19 degrees, so it's not too far from the equator. So I'll start here. This is where Arcturus is going to rise. And it's going to apex also, and it's going to go down, and it's going to set, something like that. And this would be 18 degrees. That's where Arcturus would be. That's where Arcturus would do in the sky. It's going to go up, then it's going to come down. Maybe we should draw some directions on this thing. It's going to go up, and it's going to come down. And once again, a couple things I can notice about Arcturus is it doesn't rise due east. It rises in the northeast because it's a star that sort of has this northern declination here. And so it's going to go up, reach its apex, and come down like that. And at some point at the 18 degrees, it's going to pass over the Hawaiian Islands. So let's continue on our drawing of the celestial sphere result, maybe in brown here. Vega is at 38 degrees. And so that's going to be more than 18 degrees, maybe over here. So here's what Vega is going to do. Vega is going to go up. It's going to apex. And it's going to come down again like that. And I can maybe call this 38 degrees. And that's where Vega is going to be. Vega. You should look up Vega maybe on the internet. It's a very bright star, very prominent, something to know, something like that. Okay. And lastly, I think the last star I'm going to put in here before I tell you one more thing is Dubhe here is at 62 degrees north. So that's going to be quite far north. One of the pointer stars of the North Star, one of the first stars we learned a lot about in this class, is 62 degrees. If this is 18 and 38, 62 might be way up here north. So down I go like that. So up and down. This is, what did we say Dubhe is? It's at 62 degrees. And so just think of all the lessons that I'm capturing as I do this here. The norths and the souths, and I have the stars oriented properly with one another. The ones that are further north go this way, further south go this way. So because Dubhe is part of the Big Dipper and the pointer stars, I expect I would generally look north to see it, as you know I have to do. And I feel like already I've captured a lot in this celestial sphere drawing all on my own by just capturing some of these star paths. I'll wrap up in the next video by showing you one more thing.